or we can say has inconsistent information, all will be removed. And that is all about our data reduction. So it is nothing but converting from one format to other, or we can say one structure to another. Discretization is none other than categorizing our information into different formats. So that's what discretization means. The next strategy that we can utilize is none other than discretization, which converts the information into various bins. Hello everyone, I welcome you all to the third session that's under Unit 2. Unit 2 is all about data warehouse, and the subject what we are discussing is none other than fundamentals of data science. Let me tell you, this is according to the NEP syllabus and it's for 6th semester. Alright, let's move forward and understand what is the thing that we have discussed in our previous session, that is session 2. Yes, in our last session, we have discussed and learned like what is data cleaning and why the data cleaning has to be done and all the stuff. Then followed by we also discussed the data integration, like after cleaning, what is the next step? That is none other than data integration. So how this data integration is followed, all these things we have discussed in our previous session. So let's move forward and let's see the agenda of today's session. In today's session, we will be discussing the data reduction as well as data transformation. Alright, let's begin our session and understand what is data reduction. As the name itself says, we will be reducing some part of information like some errors or inconsistent data or relationship that exists and which will be not required. Yes, those things will be reduced, and that is our next step after data integration. Thus, the result what we can expect is the data size will be reduced. Thus, it is possible by reducing the redundancies and aggregating the information or transferring the information. But the main thing what we have to note is by keeping the core data as it is. So that's the main thing what we have to note here is we will be keeping the data that's a core data undisturbed, but rest of the redundancies or repetitions, or we can say has inconsistent information, all will be removed. And that is all about our data reduction. Now, in simple words, we can redefine it as a process of reducing the data volume while keeping its usefulness undisturbed. So that is all about data reduction. But let's understand that why this data reduction is necessary. In order to promote faster processing, less storage, as well as easier analysis. Correct, right? If we have a complex information, then the processing time will be more, as well as the storage required to store that information is also high, correct? So that's why only the useful information is sufficient for us and all the other redundancies can be reduced, and that is nothing but data reduction. Here in this figure, we can observe various type of data reduction formats, like our information can be reduced dimensionally, then followed by it can be compressed. Also, we can sample our information so that we get a useful information as well as reduced complex information, followed by data aggregation. So these are the various techniques through which we can reduce our data, or we can say it has a reduce our unuseful data that is available with the processing information. Now, as we did understood what is data reduction, let's move forward and understand what is data transformation. So it is nothing but converting from one format to other, or we can say one structure to another. Now let's understand why this data transformation is required. By following data transformation, we can ensure that our information is compatible to go with other systems so that our analysis can be improved, as well as in any case if we need modeling, all can be possible. Yes, this is all about data transformation. Let me give a simple example for this. Like in your mobile phone, if your storage will be filled, then what we will do, we'll just think of a secondary memory, correct? That is the memory card, correct? So we will be transforming that useful information from our phone storage to the memory card, isn't it? So in the same way, we are transforming the information from one format to another in order to safeguard, or we can say in order to make the process easy. So this is all about our data transformation. Moving forward, let's see what are the different strategies that we can include for this data transformation. The first strategy that we can utilize to transform our information is none other than normalization, which is also called as scaling, where we can utilize or adjust the scale as min value, maximum value according to our requirements. Or we can say minimum for starting of information and maximum for ith point or the end point of that information. Great. The next strategy is none other than aggregation, which means like we are summarizing our information on the data. For example, we can say that we are storing or summarizing the daily information into a monthly format. The next strategy that we can utilize is none other than discretization, which converts the information into various bins. Example, if you consider an example of a college or a school, instead of keeping that information as it is, that's the student information as it is, you can convert them into age groups. Then it will be easy to identify and manage the data, isn't it? Yes, that's none other than our discretization. The next strategy that we can utilize is none other than encoding, where we can expect our categories of information can be or it will be converted into the numbers. The example that we can consider for encoding is like one hot coding, etc. So up next, let's see one of a strategy in depth, because that strategy is very helpful to transform the information in a very easy way. Also, we can expect that our information can be retrieved in a very good way. So that's the next thing, that is data transformation by normalization. Now, as we did understood what is data transformation, yes, data transformation is as simple as transforming our information from one format to another, and the technique that we use to do this is none other than normalization. But under normalization also we have multiple types. They are none other than, the first one, min-max scaling, and the next one is none other than z-score. So in min-max scaling, as the name itself says, we will define some values as minimum and some extent as maximum, and then we start transforming our information. So for this, we need scaling value, correct? So for that, we will be using x minus min divided by max minus min. So this is a small representation of how our normalization process, that's by using min-max scaling, happens. All right, let's see what is all about z-score, which is also called as standardization. And in order to follow this, we can use this formula, that is x minus mean whole divided by standard deviation. Great. So this is a process, that is a strategy which is utilized to transform the information. Now let's understand like why exactly we are going in depth with normalization strategy, because this will help making the process faster as well as comparing the features fairly, which is very, very important. So this is why we will go with the data transformation technique. Now let's see the second strategy that's used or utilized under data transformation. The second strategy, which is most important after normalization, is none other than discretization. Discretization is none other than categorizing our information into different formats. So that's what discretization means. But in simple words, what is it? Let's understand a bit. It means like converting continuous data into some discrete format, or we can say it has different bins. Now let's understand why this discretization is required. Discretization is utilized as it will be very, very helpful in order to go with analyzing information, handling outliers, also to work with variable algorithms or some algorithms. So that's why this discretization is utilized. Now let's understand this with a small figure. Here we can observe we have three axes and all the three axes are divided equally, isn't it? So that we have to note all the three axes are divided equally and we are representing our information between these axes. And we can say through this our performance will be increased and the data transformation happens in a very smooth way. So now let's understand how exactly the discretization happens. The first thing that we have to note is the equal width. We have to split the range into equal intervals. That's our first step. Next, we have to note that each and every frequencies that we consider must be divided into equal parts. So that's our second thing, that is putting equal frequencies under each point or bin. The next thing that we have to take care of is custom, where we will be defining bins based on various domain logics. Now let's see an example for this discretization. Let's consider the income, that's the monthly income of various people in the office. Okay, obviously the income will be different for different group of workers, isn't it? But here if you consider all together and compare them, then we can say that the income can be categorized into various factors like low income, mid income range, then the high income range and all, isn't it? Yes, that's a simple example for this discretization. Let's consider one more example and understand this in a better way. Let's consider the continuous rating of a movie starting with 1 to 10 and let's bin it or divide it, or we can also say categorize it in variable factors. We can consider 1 to 3 has low, then 4 to 7 has a mid-range. Also, the 8 to 10 can be considered as a high rating, isn't it? Yes, that's a simple example of discretization. So we have all noticed these things in our day-to-day platforms, but we don't know like what exactly that term is meant for. Through this data science, we are understanding those things in a very easy way, isn't it? Yes, this is all about discretization. Thus, we have successfully completed Unit 2 with Session 3 and see you up in the next session, that's for Unit 3. Thank you.